Having discussed the algebraic definition of curl, now we turn to the geometric definition. And so we saw this vector field at the end of the last video, negative y comma 0, and then we said the curl was 0, 0, 1. Okay, and so if we look at the sketch of this vector field, this looks oddly familiar. Hint, hint, wink, wink. And so if we kind of think about the rotation again of these plus signs, if we kind of put dots in the middle and pretend that's our fixed point, and then everything else is allowed to rotate, we would see that this plus sign in the upper left would begin to rotate in a counterclockwise fashion because the fluid is flowing more forcefully over the top versus the bottom, so it would induce some counterclockwise rotation on that one. And similarly here, if I look at this one, again, the fluid is flowing faster or more strongly on the bottom as compared to the top, so we will again see some rotation in a counterclockwise fashion. Okay, so surprise, we're going to see that we're going to have some counterclockwise rotation. Okay, and then in that other example, I want you to pause the video and see if you can identify the rotation here. Okay, well, again, if you put dots in the middle and pretend those are fixed, then again, what we're seeing is that the fluid is flowing faster over the top than the bottom, so we're going to see some clockwise rotation in both cases here. Okay, and so kind of the only difference, so yes, the direction of rotation is different, but if we look at the curl, this one was positive, this one was negative. Maybe that has something to do with all this. Okay, and so here I just want you to take a moment, pause the video, and you know how to compute the curl algebraically, and you know how to sketch the vector field. I'm just going to have you do this, and then we'll check back in here in a moment. And so what we should have found is for the curl, we should have got 0, 0, 2 just using the 2D vector formula, or 2D curl formula. And then also here in this vector field, we've kind of seen this before, but what we would imagine here is that still we have the top flowing faster than the kind of quote-unquote bottom of it, so we're going to see some clockwise rotation. Okay, so this is kind of interesting. What we have noticed so far is that if, at least in 2D vector fields, if the curl has all positive components, we're going to see, sorry, this is counterclockwise. I don't know what I was thinking. This is counterclockwise. If it has all positive components, it's going to rotate counterclockwise. If it has all negative components, or at least in that third component, the rotation is going to be clockwise. Okay, so maybe that's something we can go on. And so now, sure, geometrically, we're thinking of the curl as that microscopic rotation, as we mentioned in that very first video. And then some other things that I notice. Okay, so I want to look at the signs of all these things and just kind of understand, first of all, what m sub y and n sub x might mean. M sub y. So m sub y would be, so if I look at as I move vertically, so in this first case it would be moving vertically in along the positive x or positive y direction. The vectors, or the vectors in my vector field, are becoming less long or less forceful. So I would see the vectors decreasing in length. Okay, similarly, if we are going in the negative y direction rather, we would see as we change in x, as we move along in x, the vectors are becoming less longer or less forceful in the y direction as we go down the negative y axis. Okay, so and both of these, if you can imagine just a little object in here, we would induce kind of counterclockwise rotation. Okay, similarly, if n sub x is greater than 0. So this is, again, we're looking at changing in the change in x as we move along in y. So here, if we're going to the right now, also along the positive x direction, we're going to see the vectors having longer length in the y direction, meaning that the vectors are stronger as we go further to the right. And so again, this sort of scenario would induce counterclockwise rotation. And then if we're moving now to the left, and we imagine a little object in here, this is as we go to the left. So as we progress along in x, the vector lengths are becoming greater. So we would see, again, counterclockwise rotation here. All right. So then now, if we put these all together and look at the signs, okay, sine of n sub x minus m sub y, okay, if we think about this very carefully, maybe we'll come back to this, but n sub x minus m sub y, if that is greater than 0, that was in our second example, our first example, where the curl was 0, 0, 1, we ended up getting counterclockwise rotation, right? Versus if the curl was negative, then we got clockwise rotation. So really, when we look at the sign, then this is going to give us the direction of microscopic rotation. Okay, this does not describe global rotation. That's more given by the vector field. Okay, and then at least in 2 dimensions, this is going to be about z-axis. Okay, and then n sub x minus m sub y is 0. We would say that there's no rotation. No rotation. And then the language that we use for this, just so you're all aware, is irrotational. Okay, and then a couple other things to go with this. So this is that last part was very important. But when we think about the absolute value of n sub x minus m sub y, which really is the length, since we only have one component in our 2D curl, we identify the length here as really the speed of rotation. Okay, and just a quick example here, and then we'll conclude this video. Alright, so if I'm computing the 2D curl of this, I want you to pause the video and try this on your own, and then resume when you're ready. Alright, and if you did pause the video and work through the example here, you should have got 0, 0, 0 after a little bit of algebra. I did skip it just because I didn't want to write it out. You do get 0, 0, 0. Okay, and so this field, what we would say is that it is irrotational on a microscopic level, but if you look at, and this is that falstad.com applet that we've used before, if you look at the 2D vector field on here, what you end up seeing is that there's, and all these are of unit length, there is global rotation. So just keep in mind that irrotational doesn't mean that it isn't moving. It means that it isn't moving at a microscopic level. Okay, so that's going to be the end of this video. We have a little bit more geometry to discuss, so that'll be in the next video for when we discuss how this affects 3D vector fields.